So last week we talked about adding, subtracting, and multiplying polynomials. Today we're going to move into using Pascal's triangle to help me multiply binomials to even higher powers, okay? So for example, down here at the bottom of your paper, okay, what I would like for you to do is write out x plus 2 raised to the 7th power. X plus 2 raised to the 7th power. Well, what does it mean when I raise something to the 7th power? How many times do I need to multiply it by itself? 7 times. So I'm going to write that out. One, two, three, four, five, six. One more. Now, who in their right mind wants to multiply all those little pieces together like that? Not me. To me, that's pretty time consuming, okay? So what we're going to do, we're going to use Pascal's triangle, and we're going to let that help us. It's kind of like our shortcut, okay? So starting out with Pascal's triangle. The very first thing that I need you to know is that I'm always going to start with a triangle of ones at the top. You will be asked to build this triangle without the shape, okay? So if I'm building it without the shape out to the side, I could do my triangle of ones out to the side. Okay? Now down the diagonal, the very first number for every single one, I'm going to have ones down that whole diagonal, okay? Now, Pascal's triangle is infinite. I could keep going, I could keep building it, okay? It never ends. But for our purposes today, we're only going to do a certain amount, okay? Now, right here, also down the other diagonal, it's going to end with a 1. So I start with a 1 and I end with a 1. Well, how do I get the numbers in the middle? I am going to simply use the two numbers directly above it. If any of you have ever been part of a cheerleading squad or a dance team, do y'all know how we ask you to line up in windows where people are, like you've got two people and then one person who's kind of between them? Okay, ooh, goodness, sorry about that. Right here, I'm going to take the two numbers that are above it and I'm going to add them together to give me the number to fill in its window. So 1 plus 1 is 2. All right, on the next row, I'm not going to worry about this 1 that's over here, but I'm going to use the 1 and the 2. 1 and 2 together give me 3. And then I've got the 3 and this 1, the 2 and the 1, that's going to give me another 3. I'm not going to draw my little arrows like that every time. Just know that this bubble is going to be filled in with the 1 and the 3 added together. 1 and 3 together is 4. 3 and 3 added together is 6. 3 and 1 added together is 4. So this row is 1, 4, 6, 4, 1. All right, the next row, help me out. What would I have? Right here, I've got to start out with a 1. 1 and 4, 5. 4 and 6, 10. 6 and 4, 4 and 1, okay? So this row is 1, 5, 10, 10, 5, 1. It's kind of symmetrical, right? Do you notice that? Whether I've got a perfect number, like a number in the middle, it's got the same numbers on either side of it. Or if I have the same number doubled in the middle, okay, it goes back out symmetrically. All right, what would the next row be? 1, 6, Good. And 6. Good. All right, the next row. 1, 7, 21, 35, 35 again, good. 21 and 7, and then end with 1. Okay, the next row. 8. Okay. Okay, very good. 70. Then I start going backwards again, right? So 56, 28, and 8. All right. It is a pattern, okay? I like that. All right, so do me a favor. Build the last 2 rows. Build the last 2 rows. So filling in the next row and then the bottom row of the triangle I've got right here. Okay, what would this row be right here? 1, 9, 36, 84, bless you, 126, 126, and then it starts going backwards again. So 84, 36, and 9. All right, the last row. I'm sorry the bubbles didn't line up the way they should have. Okay. All right, filling this in. 10. Gracious. 45, 120, 210. Okay. And then going backwards again, right? Okay, now I typically won't ask you to calculate anything with those big of a number, okay? We could go, however, to whatever power is fine, but it doesn't, as long as you know the process, we're gonna be fine. So over here, if I am building my Pascal's triangle without the box, remember we start out with my triangle of 1s, okay? And then I would do 1s on the beginning and the end. And I'm going to stick the 2 in the middle here because 1 plus 1 is 2. And then I would go again for the next row. 1, 2 and 1 give me 3. 2 and 1 give me 3. And then I end with 1. And I could keep going and building it without the little shape to fill in, okay? We don't have to have the shape to fill in. The next thing we need to know is how to name my rows, okay? This row right here at the very top, that very top one is what I call my 0th row. If I raise anything to the 0 power, what do I get? 1. Anything to the 0 power is 1, okay? So whatever I've got, if it's in parentheses, if I've got multiple things, it doesn't matter. If it's in parentheses and it's raised to the 0 power, the whole thing is just equal to 1, okay? This one right here, I call my first row. Then I call this one my second row. Then I've got the third row, and so on. Does everybody see? It should be pretty easy to tell what row I'm working with because the number of the row is the number there in that second spot, okay? So what row have I built Pascal's triangle up to? The 10th row. So I'm going to do that real quick. I'm going to write these down. But do you see how this triangle is infinite? It could go on forever and ever just by me simply building it up, okay? All right, so we're going to use this to help us with actually expanding the binomials, okay? Michael, will you do me a favor and hand out the binomial theorem note, practice right here? Yes, sir. Okay, so this paper is going to come around to you. And this is where we're going to use 3 highlighters. Now, I typically use yellow, pink, and blue. It does not matter what colors you use. Just know these are the colors that I'm going to use. I am pretty OCD about having things color-coded just so they're helpful to me in the long run. Okay? Okay, so right here, we are going to learn how to expand my binomials completely. I'm going to use my exponent to help me pick out the row of Pascal's triangle that I will use, okay? Now last week, when we were just multiplying polynomials, we said that this right here, if I write it out 2 times, and show that I am multiplying those 2 together, I'm going to get my answer, okay? And honestly and truly, just distributing this stuff like we did last week is much quicker when I've got the second power. So that would be my recommendation. But if I ask you to use the binomial theorem to show this, then I need to see what we're about to do, okay? So, grab your first highlighter. I use yellow. And I'm going to highlight my exponent. And I'm going to make a row that's yellow. Okay? Then the number or numbers that sit in the first position inside my parentheses. Here I've got 4A. So I'm going to highlight that pink. And I'm going to draw another row. And then lastly, I'm going to take my third highlighter and I'm going to highlight whatever number, positive or negative, is in the back position. And I'm going to do a third row. Okay? Now, since it asked me to raise it to the second power, that means I need to use the second row of Pascal's triangle. So the numbers that I'm going to write spaced out on that top row is 1, 2, 1. Okay? 1, 2, 1. These are what we call the coefficients of my binomial from Pascal's triangle, okay? All right, next, I'm gonna take this number that sits in the front position. So I've got 4a, and I'm gonna write it underneath every single number. But I want to get in the habit of making sure that I put everything I've got in parentheses. Okay? For this first row, I'm going to start with the power that it asked me to use to expand. So 2, and then I'm going to decrease my powers. 1, and then 0. But I have a quick question. What did we say that anything raised to the 0 power is equal to? 1. So I'm going to slash this whole thing out, and I'm going to turn it into a 1. I'm just going to write a 1 right above it, okay? And then on the last row, I'm going to take the number that I've got, and I'm going to list it out underneath every single number from Pascal's triangle. Again, I want to put parentheses. But this time, instead of starting with 2 and going down with my powers, I'm going to start with 0 and increase my powers. Okay? Now, everything I do next, I'm going to be simplifying vertically, okay? So I'm going to put all this stuff together vertically that I've got. May I use your calculator for just a minute? Thank you. Okay, so here we go. I'm going to use my calculator to help me out with this, okay? Clear out what I've got. All right, right here, I have 1, and then right here, I forgot to do this. If I slash that one out, what does that one become? Another 1, okay? Everything that I do vertically is going to be multiplied. When I distribute my exponents, please make sure that you distribute your exponent to the number and the variable or variables that may be there, okay? So, a lot of this is going to be very redundant, but I'm just going to teach you how I'm going to use the calculator as I move along to help me out, okay? I have 1 times 4 to the second power, oops, use my arrow, and then that's going to get multiplied by 1, and I'm going to hit enter. What does that give me? 16. Really, I could have just done that a very quick mental calculation. 1 times 1 is 1, and then 4 squared is 16. So this first term is going to be 16, and then my variable here, a to the second power, so a squared. Okay, 16a squared for that first term. Then I'm going to move to the next one very quickly. Okay, I have 2 times, I have 4 raised to the first power. I know that that's pretty redundant, but again, I'm just trying to get in the habit of putting my powers in. This 1 gets distributed to the 4 and the a. And then that is going to be multiplied by, notice what I'm putting this in parentheses. That also gets raised to the first power. Those parentheses are super important when we're raising negative numbers to a power. Okay, I hit enter, I got -8. So this is going to be -8 a to the first power, so I don't have to write the 1. Okay? And then down here, this last part, I have 1 times 1, because that whole thing became 1. And then that's going to be multiplied by -1 squared. -1 squared. That -1 went in parentheses. And that gave me a +1. Okay? So when I multiply -4a minus 1 by itself, this is the polynomial that I will get. Okay? Again, I could have found that much quicker just by the distribution, but I just wanted to teach you very quickly how we're going to use the binomial theorem, okay? All right, let's look at number 2, please. Number 2. Okay, for number 2, I have 5x minus 1 raised to the third power. I'm going to highlight that third power, and I'm going to draw my yellow row. Whatever color you have is fine. I've got 5x in the first position. That's going to get highlighted pink, and I'm going to make a pink row. And then I've got this -1 again that's going to go with my blue row. So my highest power is 3. That means I need the third row of Pascal's triangle. Okay, the third row of Pascal's triangle, I have the numbers 1, 3, 3, and 1. So I'm going to write those numbers across the top on here. 1, 3, 3, 1. The first position was 5x. So I'm going to write 5x all the way across. What am I going to put around that 5x? Parentheses. What power will I start with on this one? Start with your highest power, 3, and then decrease, 2, 1, 0. What happens to that back term? It just becomes a 1. Okay? And then right here on the last part, I've got this -1 again. I'm going to write it across. I'm going to put it in parentheses. The power that I start with here is 0, and I go up 1, 2, 3. This one will also cancel out and just become a 1. Okay, so then I'm going to work on simplifying vertically. What operation will I do vertically? Multiplication, okay? So I have 1 times 5 raised to the third power, and then this gets multiplied by another 1. Okay? What is 5 to the third power? 125. So 125. And then what will my variable be here? X to the third. Good. That's X is my only variable for this one. But remember, we got to distribute that exponent to both the number and the variable. Okay? All right, for the next one, I have 3 times 5 squared times -1 to the first power. Again, remember, I am putting that -1 in parentheses, okay? And I get -75 as my number. What variable will go with that? X squared. Awesome. Okay. Next, I have 3 times 5 to the first power. I know it's going to be 5, but I'm just going to go with it. Times -1 to the second power. Not times 2. My goodness. That's wrong. Sorry. Okay, I have 3 times 5 raised to the first power times -1 squared. I got +15. So plus 15 what? X. Notice my powers are decreasing, right? Okay, and then right here, this whole thing went away. What is 1 times 1? 1. What is -1 cubed? If I multiply -1 by itself 3 times, I get -1. Okay, so this is it for number 2. If I were to multiply this by itself 3 times, this is the answer that I would get in the end. Okay, y'all sit up and pay attention, please. Okay, all right, let's look at number 3. What do you notice real quick about the numbers inside number 1 and number 2? What about that back number? They're both negative. Look at what happened to my signs. I've got positive, negative, positive. Here I have positive, negative, positive, negative. My signs are doing what? What do I call that? Alternating. Let's watch what happens when it's strictly positive. Okay? All right. So here we go. 4th power. What row will I need for Pascal's triangle? The 4th power, or the 4th row for the 4th power. Okay? M sits up front, so it's going to be my pink row. And then this 4 sits in the back. It's going to be my blue row. Okay, look at your Pascal's triangle. What are the coefficients or the numbers in that 4th row? 1, 4, 6, 4, 1. Okay, then I'm going to come write M underneath every single one. And just out of habit, okay, I'm going to come and I'm going to put parentheses around every single one of these. Tell me what my powers will be from left to right. 4, 3, 2, 1, 0. They will be decreasing. That is correct. Okay? All right, then I'm going to write down the number that's in the back. That happens to be a +4. So I'm going to write that down all the way across. And again, I'm going to get in the habit of putting parentheses just because I don't want to mess up my signs, okay? This time my powers are going to start at 0 and go up. I'm going to slash through that first one. Both this piece and this piece back here became 1. All right? So using my calculator, I'm going to skip over my calculator for this first one because what are all my numbers that I'm raising to powers? Ones, which is just going to give me 1. And then I've got my variable with its power. So m to the 4th power. Okay. Then I have 4 times 1 raised to the 3rd power. I really could have skipped over that. Times 4 raised to the 1st power. And that gives me 16. It gave me a positive 16. So that's 16m to the what power? 3rd. Good. All right. Then I have 6 times 1 to the 2nd power times 4 to the 2nd power. That gives me 96. So plus 96 m what? Squared. Okay, then I have 4 times 1 to the 1st power. That's just going to be 1, duh. And then times 4 to the 3rd power. That gives me 256. Times m to the 1st power. That's right. And then here, notice my variable is gone, right? I marked it out. What is 4 to the 4th power? 256. So notice my powers went 4, 3, 2, 1, 0. This right here is my binomial expanded completely. Okay? All right, flip to the back side of this page. We're going to skip number 4. And I want us to look at number 6. Number 6. Okay, first of all, it's to the 5th power. But second of all, I've got numbers and variables in both positions. Okay? Okay? I've got my highest power of 5. So what row of Pascal's triangle will I use? The 5th row. Good. 2a sits in my front position, so it's going to go in my pink row. And 3b, positive 3b, sits in the back position, so it's going to be my blue row. Okay, now it's going to start getting kind of cramped, okay, as far as space is concerned. What are the numbers in my 5th row of Pascal's triangle? 1, 1, 5, 10, 10, 5, 1. All right, so then I'm going to do 2a all the way across that pink row. I'm going to come put my parentheses in. I'm going to start with my highest power, which is 5. And I'm going to decrease to the right. Okay, I need for y'all to sit up, and I need for you to pay attention. I asked y'all to not talk because of this. That does not mean you get to sleep. He's mine too. Next, I'm going to do 3b across the bottom. That's not a 36, that is a B. And this time I'm going to increase my powers. These two cross out, and they become ones. Okay? All right. So again, multiplying vertically. I probably will run out of space this time, but I'm just going to try and scrunch it in as much as I can, okay? All right, here we go. I have, with my calculator, I'm going to use, see, I'm going to move this out of the way for a minute. I've got 1 times 2 raised to the 5th power, and then 3 to the 0 power. I could do that if I wanted to, but I really don't need it. Let me come back and insert to my multiplication. Okay, I'm going to hit enter, and I've got 32. So this first position right here, I get 32 what? A to the 5th. All right, why do I not have a B right there? Because it crossed out and became 1. Okay, all right, next. I have 5 times 2 raised to the 4th power times 3 raised to the 1st power. What does that give me? 240. So 240, this time what are my variables going to be? A to the 4th, B to the 1st, okay? So be careful. Somebody said AB to the 4th. This 4 belongs to the A and the 1 belongs to the B, okay? All right, next, I'm going to go to my next column. I've got 10 times 2 to the 3rd power times 3 to the 2nd power. Oh my goodness. I'll redo that. Don't forget to hit your down arrow. Okay, hit enter. And that gives me 720. So plus 720. A to the 3rd, B to the 2nd. Good. Notice how it's getting off as far as like lining it up vertically. It's okay. Just make sure you don't skip over a column, okay? All right, next, I have 10 times 2 raised to the 2nd power times 3 raised to the 3rd power. That gives me 1080. So plus 1080, what are my variables going to be? A squared, B cubed. All right, I've got 2 more columns to do. Next, I'm going to do 5 times 2 to the 1st power times 3 to the 4th power. That gives me 810. So plus 810. What are my powers going to be here? My variables and powers. A to the 1st, B to the 4th. And remember, I don't have to write the power for A. All right, and then the last thing that I'm going to do is this last column. I have 1 times 2 to the 0 power, but that's just going to become 1, times 3 raised to the 5th power, which is 243. So plus 243, B to the 5th. Notice my powers of A. They went 5, 4, 3, 2, 1, 0. Okay? So that is in standard form. All right, that is my polynomial for expanding it to the 5th power. Okay, Last one we're going to do together, and then you're going to have to do some on your own. Let's look at number 8, please. This one should be quick and easy. Going to do my rows. Yellow, pink, then blue, or whatever colors you have. Just keep it consistent. My bad. All right, for the 6th row of Pascal's triangle, what are my numbers? 1, 6, 15, 20, 15, 6, and 1. Do you see how we run out of space just because it gets hard to write everything down? Okay? All right. I'm going to go through, I'm going to put my X's down across the pink, put in my parentheses, start with the highest power and decrease. 6, 5, 4, 3, 2, 1, 0. That crosses out, becomes a 1. Then I've got my negative y's. What number is understood to be in front of that y? Negative 1. So I'm going to write that in. Negative 1y. Just because I don't want to miss raising a number to a power. I'm going to start my power at 0 and work my way up. Cross that one out as well. All right, so simplifying vertically, okay? I've got 1s this way. So that's just 1 x to the what power? 6th power. All right, what is negative 1 to the 1st power? Just negative 1. It's itself, right? So that's going to be negative 1 times 6. So negative 6, what power of x will I have? 5th. What is negative 1 squared? Is positive 1. Anytime I raise that negative number to an even power, it's going to be positive. So positive 1 times 15 is 15. Oh gosh, y'all, I skipped my y right here. Okay, so x to the 5th, y to the 1st. Let me squeeze that in there. So what are my variables and powers going to be with this 15? X to the 4th, y to the 2nd. That's real easy to do. My bad. I'm sorry about that. Okay? All right, negative 1 cubed, it's raised to an odd power, so it's going to stay negative. Negative 1 times 20 is negative 20. X to the 3rd, y to the 3rd. All right, negative 1 is raised to 4, so it's positive 1 times 15, so plus 15. X to the 2nd, y to the 4th. Okay, I'm about to run into this hole, so I don't want to, I'm going to drop down to the next line. All right, negative 1 to the 5th power, it's raised to an odd power, so it's negative. Negative 1 times 6 is negative 6. X to the 1st, y to the 5th. And then this is going to be a positive 1 for the last one, times 1. So just plus what? 1y to the 6th. okay? So here is your job, okay? This is your assignment for the remainder of class and for this evening, okay? You need to do number 4. Please don't pack up. I have not given you permission to pack up yet. Number 5, number 7, and number 9. You have 4 problems that you need to complete. You need to make sure you keep up with the Pascal's triangle, okay? Otherwise, you're going to have to build it again, okay? All right, we're going to check those tomorrow.